Alright, so this is a CS50 supplementary lesson on pointers, and to sort of show you an example about how pointers actually work in a computer program and the consequences of a segmentation fault, I'm going to talk about a video game for a sec. So Final Fantasy IV was a role-playing game released for the Super Nintendo, and a big part of the game is you going in between these various rooms and kind of exploring the world through maps. And basically, there's a glitch in the game that's interesting called the 64 door glitch that specifically shows you how referencing pointers can go horribly wrong. So basically, when the game handles map transitions, as in you're like going through one part of the room that will like transition you into the next part, it will keep track if it is a go type, which is supposed to save your location, a return type, which is supposed to put you back to another location, and it uses a non-negative integer, which is from 0 to 63 in order to keep track of this. And now one reason for this is because there's a spell called Warp that's supposed to send you back -1 floors when you're not on the world map. The world map sets this counter to 0, entering a go transition will increment the number, and entering a return transition will decrement the number by 1. Since no room in the game ever has like 64 floors, ordinarily this isn't something you have to worry about. And since the warp spell is disabled on the world map, this should work just fine. However, because of a programming oversight, there are some rooms where the counter will only ever go up as you go through the transition parts. So there are some rooms in the game where you can walk back and forth and keep incrementing the counter up and up and up. And when this counter is incremented past 63, the room counter will reset down to 0. Now, if you're to use the warp spell after this point, it will still decrease the number, and it will essentially make the number negative now. And because of this, this is essentially dereferencing the pointer, because now that it's not pointing to that specific room counter, it's now going to start reaching into the rest of the memory within the computer to try and figure out where do I send the player. And this is where it gets kind of interesting, because now it will start pulling into literally every single part of the data to send you somewhere on the map. So this is a little chart short of showing this, but when the room number gets this low, the pointer will start referencing things like where you park these particular ships. Do you, a couple of flags, check what ship you have. And at some points we'll even start checking like the audio settings you have, because again, since the pointer is dereferenced, it will start referencing everything stored within the game's memory to try and figure out the map ID and the actual map coordinates to send you to. And this is a prime example of a segmentation fault where, because it's not reaching the memory that it's supposed to, this can cause a bunch of effects like distorted maps, and generally like going to places you're not meant to. Now, this seems tricky, but it actually can be manipulated, because if you, for example, there's some speedruns that can take advantage of this, where if you park your ship to certain locations and change your menus to be a certain color, you can use that so that you can get set to the X, Y, and map ID of a very particular spot, so you can like essentially go to like almost any map if you know how to manipulate it. And speedruns take advantage of this to go to the final level of the game. Now, here it's just kind of funny because, it's just kind of a weird, wacky, distorted glitch, but outside of stuff like video games, segmentation faults can cause serious problems when you have programs trying to reach into other parts of the memory of the computer that can maybe end up damaging it or causing a whole bunch of other issues. So when you're in the Cs50 IDE, it will exit out of a running once you reach a segmentation fault, so you don't have as much of an issue. But in general, you do need to be very careful about when you're storing memory and when you're assigning a pointer to it and making sure you're dereferencing it. Because if you reference memory outside of what you're supposed to, you can cause some very serious problems within the program that you're running. So that's it for this supplemental lesson. If you have any other questions, feel free to reach out, and keep on programming and have a good day.